Earth, the only life-sustaining planet in our solar system. Yet throughout its history, our world has been a planetary punching bag.
Anything that crosses the orbit of Earth could one day slam into the Earth.
At this very moment, violent celestial heavyweights roam the universe and threaten to deal the Earth a knockout blow.
The power would be like setting off the whole world's armament at one time. It would be like standing next to Hiroshima all over the world.
Everything in us would get ripped apart, and your body would fly off to infinity.
But some scientists and former astronauts are not willing to go down without a fight. They're racing to track down these cosmic killers before they trigger Armageddon. Earth shimmers like a sapphire jewel in our solar system. We go about our days unaware that in the far reaches of space, trouble could be headed our way.
Our solar system is a lot like an amusement park. Earth and most of the other objects carve predictable paths around the sun. Normally, everything is calm and smooth. But at times, things get chaotic and violent. Earth can be slammed by space rocks, zapped by deadly space weather, jolted, jostled, and threatened by the object's energy and forces of the cosmos.
The Earth is on a cosmic thrill ride, one that often involves extreme danger.
When you're moving fast and on a predetermined path, you hope nothing crosses it because there's nothing you can do.
Nicaraguan border goes right down along.
Former astronaut Rusty Schweickart knows firsthand how dangerous celestial objects can be. In 1969, he piloted the lunar module during the Apollo 9 mission. Now, Schweickart is ready for more than a cruise through the cosmos. He's sounding alarms about the dangers of one particular asteroid named Apophis, which got too close for comfort in 2004.
It immediately got everybody's attention because the probability of impact was quite high. In fact, it was higher than any impact probability that we had ever seen up until that time.
And Schweickart has a terrifying real-life example of just how damaging an impact from an asteroid even smaller than Apophis could be. June 30th, 1908, 7:15 a.m. An object half the size of a football field plunged down from space at around 34,000 miles per hour and produced a stream of fiery gas behind it. Within minutes, the fireball entered our atmosphere and violently exploded above Siberia's Tunguska forest. It became the largest explosion on Earth in modern human history. The blast sparked heat waves, which torched 80 million trees in an area over half the size of Rhode Island. Fortunately, no one died as a direct result of the explosion, because it was in a thinly populated area.
If that asteroid hit just a few hours later, it would not have hit Siberia, it would have hit over Europe. And if that had exploded midair over any of the major cities of Europe, 1 million people would have died like that.
For the last 100 years, the Tunguska explosion has been shrouded in controversy. Today, many scientists agree an asteroid caused the blast. Incredibly, it never even impacted the ground. Rather, it exploded 5 miles above Siberia's frozen ground.
A small stony asteroid can't survive the plunge through Earth's atmosphere. When it smacks into the lower atmosphere, doing about 50,000 miles an hour, it's like an egg smashing onto concrete.
The blast over Siberia released energy equivalent to 15 megatons of TNT, 1,000 times greater than Hiroshima. If this were to happen over a large city, it would annihilate it. Scientists call these trespassers near-Earth objects, or NEOs. They're asteroids and comets, which are leftovers from the formation of the planets. Comets move in the Oort cloud and the Kuiper belt, which is beyond the planet Neptune. Asteroids travel in a band between Jupiter and Mars, but their orbital trip isn't always routine.
Most of the asteroids orbit in a neat belt between Mars and Jupiter, and we don't worry much about those. But when one gets away and all that mass and energy is headed towards Earth, that's when the astronomers start to worry.
Oftentimes, these cosmic remnants get bumped out of their orbit and head on a collision course with Earth. Our planet's thick atmosphere vaporizes the vast majority of them. But a larger object can knock through our atmosphere and actually impact the ground.
If you want to turn to the cosmos and look at the forces that would have us dead, asteroids striking are real and they're bad. It's happened before, it will happen again.
65 million years ago, an asteroid the size of a small city plummeted down from the sky. It exploded in the Yucatan Peninsula near the present-day Mexican village of Chicxulub with a force of 100 million megatons of TNT.
It hits the Earth, cast billions of tons of Earth's crust into the atmosphere, cloaking Earth, blocking out sunlight, knocking out the base of the food chain, and sending a wave of extinction across the tree of life.
It is believed the ferocious impact contributed to the mass extinction of the dinosaur.
We can think of asteroids as being bad things, but were it not for an asteroid, we wouldn't be here today. Our mammal ancestors were running underfoot, trying to avoid being hors d'oeuvres for T-Rex. T-Rex gets taken out. Well, this opened up an ecological niche that allowed our mammal ancestors to evolve to something more ambitious than a rodent. And out comes the primates, and among the primates we have people.
But ironically, the very kind of cosmic boulder that paved the way for humans to exist may one day wipe us off the planet. In 1998, Congress urged NASA to detect all the near-Earth objects over a half-mile in diameter or more. And what they found was unsettling. Over 850 NEOs in our vicinity. These asteroids are our closest and most dangerous neighbors in the solar system. Donald Yeomans heads the NEO program at NASA's Jet Propulsion Laboratory. He and his cosmic bounty hunters search for potential killers lurking in our solar system and put them on their most wanted list.
Finding these near-Earth objects is somewhat akin to tracking hurricanes. As you track it day after day, you get a better idea of its orbit. You can predict where it's going. You have a better idea of how large it is and if it should hit the Earth, with what sort of velocity.
By using telescopic technologies, NASA's Space Guard survey has detected over 90% of all NEOs deemed harmful. These frightening objects could strike the Earth with the energy greater than all the nuclear weapons on our planet today. Such an impact could trigger mass extinction.
You wouldn't expect one to hit but every several 100,000 or millions of years, but if one did hit, it could wipe out a fair fraction of the population. So they're very low probability events, but high consequence events.
If they hit the Earth, they would have global effects. I mean, not only would you wipe out a continent with really heavy shock waves, but the ejecta would be thrown up in the air and come down all around the planet. The atmosphere itself would get to 1,000 degrees or so, and all the vegetation all over the world where that happened would flash into flames.
Cataclysms could also occur with smaller objects. So Congress now asks NASA to locate all NEOs 500 feet in diameter, as wide as the Roman Colosseum. An object that big could decimate a metropolitan area or even a small state. And what worries scientists most is not the asteroids they've discovered, but the ones they have not yet found.
At any given time, there's about 24 objects for which we can't yet rule out an Earth impact.
Former astronaut Schweikert has taken the threat of NEOs one step further. He's appeared before Congress to request a special government agency be responsible for protecting the public from space rocks.
Today, we have the technology to stop near-Earth objects from impacting the Earth for the rest of history. I mean, we can literally now begin to reshape the local solar system so that our survival is enhanced. The question is, will we? Or will we go the way of the dinosaurs?
But Schweikert isn't waiting for NASA or Congress to solve the problem. He has his own plans to save the planet from the next asteroid impact. It's hard to believe the Earth has survived over 4.5 billion years, because since its infancy, the planet has taken a beating. Like a boxer, our world is under constant assault from asteroids that enter our orbit each year. But in the future, Earth could be knocked out. Former Apollo 9 astronaut Rusty Schweikert refuses to be bullied by asteroids. And now he's ready to defend Earth against these harmful rocks.
We've discovered that there are these near-Earth objects flying by us all the time. And we've gotten more and more capability to modify our environment to enhance our survival.
Schweikert is particularly concerned about an asteroid named 2004 MN4, better known as Apophis. This pockmarked rock, approximately 750 feet in diameter, swept near Earth in 2004. Now it's scheduled to pass dangerously close to our planet again on Friday the 13th in April 2029.
So in 2029, Apophis will come closer to us than our own communication satellites orbiting the Earth. It will be so close that people who are in the right place will be able to see Apophis go by the Earth with your naked eye. You won't even have to have binoculars. That's how close that asteroid is going to come.
Apophis has an over 99% chance of missing the Earth in 2029. But if Apophis passes the Earth at a distance of exactly 18,893 miles, it may pass through a gravitational keyhole, a narrow region in space a half-mile wide. If this happens, the Earth's gravity could upset Apophis and change its trajectory. It could cause it to return and hit Earth 7 years later on April 13th, 2036.
The gravitational effect of the Earth will cause it to bend, cause the Apophis orbit to enlarge to precisely the size which 7 years later it will come around and hit the Earth.
At the present time, Apophis has a 1 in 45,000 chance of delivering a deadly blow in 2036. But even these odds have scientists placing bets.
It's one thing to know that there's maybe 1 chance in 45,000 that it's going to hit the Earth, but what you'd like to know is there 1 chance in 100? Is there 1 chance in 10? Is the probability 1 that it's going to hit the Earth?
Schweikert believes we must regard Apophis as we would any natural disaster. He's even mapped out where Apophis might strike.
You have the date of the impact, the time of the impact, the orbital inclination, and you can make a map. And what that map shows is what I have called a path of risk that goes all the way across the planet. And I look at this and I see a high probability of impact and I say, whoa, you know, where might it hit?
According to Schweikert, Apophis could impact any point along this path of risk. It begins in western Siberia, cuts across and down the Pacific Ocean near California. Then it traverses Central America and finishes in Western Africa. Schweikert proposes a chilling scenario of where Apophis might strike. The asteroid could land in the Pacific Ocean off the coast of California with the force of over 1 million megatons of TNT. Such an impact would create a 5-mile wide, 9,000-foot deep crater in the water, which would unleash tsunamis. Relentless 50-foot waves would pound the coastline, resulting in unimaginable human loss.
An asteroid that's 1,000 feet in diameter, having a hit in the ocean is not a good deal. Hundreds of billions of dollars of damage for something like that.
Scientists are presently working on technologies to preempt such a cosmic strike. One idea involves blowing up an asteroid. But some feel this could compound the problem, sending several chunks of the asteroid in our direction instead of just one. Consequently, Schweikert's new mission is to change the orbit of asteroids that could impact Earth.
What you want to do is basically change the asteroid's orbit very, very slightly. You change its velocity by a 10,000th of a mile per hour so that it will miss the Earth instead of hitting it.
Rusty's colleagues have drafted conceptual designs of spacecraft that could deflect asteroids, particularly Apophis. One would tow harmful asteroids away from Earth, but instead of lassoing the rock like a bull in a rodeo, the tractor will hover in front of it and use gravity as a tow line.
If you park in front of an asteroid for a long enough period of time and you stay close enough to it but not touching it, you're going to increase its velocity. Or if you park behind it while it's moving along, you're going to slow it down very slightly. We can change the orbit of an asteroid if we know about it far enough ahead of time.
Although a space probe has landed on an asteroid in the past, the most challenging idea is launching a manned mission. Once landing on the rock, astronauts could mount a radio transponder to track its whereabouts.
You could just use a robotic mission to go to an asteroid, land, grab a sample, and bring it back. That's not that difficult. What you gain by a manned mission is they can react to interesting areas on the asteroid surface. They could go here, there, and they wouldn't have to rely on remote navigation.
Nicaraguan border.
Schweikert insists we should remain on high alert regarding asteroid Apophis, and his cause hasn't gone unheard. Now the United Nations plans to draft a treaty which will include who will be responsible for deflecting killer asteroids.
That would be a real crime if we are so irresponsible, knowing that this is going to happen, that we continue to do nothing about it.
But asteroids and comets are not the only deep space threats.
All
Earth has had its ups, and Earth has had its downs. We never know what's going to be around the next corner, and a lot of it is bad.
In far-off galaxies, galactic invaders are at work, itching to end life on the planet as we know it. 3 times daily, a strange flash pulsates across our sky. It's hundreds of times more powerful than the world's total nuclear armament, but it's not man-made. And if one happens close enough to Earth, it could end life on our planet. Most Earthlings are unaware of the potential hazards in space, but the list is long and growing. Imagine this. Within our own galaxy, the Milky Way, a massive star explodes, sending a lethal burst of energy rocketing toward our planet. This is a gamma-ray burst, the biggest explosion to rock the universe since the Big Bang. In the cities and countryside below, there's no warning of what's about to happen. And then it strikes.
It would be equivalent to standing 1 mile away from Hiroshima, any place on the Earth.
The potent radiation cooks the upper atmosphere. Our ozone layer roasts. Across the hemisphere, human beings burn to death from radiation 100 times the fatal dose. The disappearing ozone layer causes increased temperatures around the world, triggering cyclones, tsunamis, and hurricanes. Most life on the surfaces of land and water incinerates. This may seem like science fiction, but it could happen if a gamma-ray burst hit Earth from 100 light-years away.
Gamma-ray bursts are the brightest explosions in the universe. Because they're so far away and yet still so brilliant, they must involve an enormous amount of power. As much energy as the sun will emit in its entire 10 billion year lifetime.
As a young student, Stan Woosley always liked experiments that go boom. Now, the work of this astrophysicist is more than child's play. He's one of the galactic detectives trying to uncover the mysteries behind gamma-ray bursts.
We know there are many planets and many stars throughout the cosmos, so there may have been countless civilizations that were destroyed by gamma-ray bursts.
These peculiar beams of radiation were first spotted in the 1960s. At first, most astronomers believed these gamma-ray bursts must exist in our own galaxy, the Milky Way, because they're so bright.
There were reasons for that. One was that if they were outside the galaxy, the energy was almost unbelievable.
But at the time, even the most powerful telescopes couldn't determine their location and distance, because the bursts lasted for a few seconds, then disappeared. But then astronomers wondered, what about their afterglow? Cosmic explosions typically leave behind some luminous residue that sometimes lasts for days or weeks. In the late 1990s, satellites used upgraded optics and X-ray detectors to finally capture a gamma-ray burst's afterglow.
It became clear that gamma-ray bursts actually were cosmological, coming from very far outside of our galaxy, from millions and billions of light years away. And that meant their energy had to truly be astronomical.
To get some idea of how incredibly bright a gamma-ray burst is, we could represent the brightness of our sun by this relatively dim LED, and we could represent the brightness of the gamma-ray burst by the very, very intense searchlight that's behind me. Isn't that incredibly bright? Unfortunately, with this comparison, the searchlight is not nearly bright enough to represent fully the gamma-ray burst, and in fact, we would need 100 billion such searchlights to have an adequate comparison. The gamma-ray burst is equivalent to the brightness of 1,000,000 trillion suns.
These massive bursts could decimate Earth. But what causes them?
We are quite convinced that the common gamma ray burst comes from the death of a massive star, at least 10 times the mass of the Sun. And such stars are quite rare, by the way.
Woolsey masterminded a groundbreaking model of how gamma ray bursts may be created. When an extremely massive star dies, it collapses into a black hole. Black holes are created when a collection of matter collapses to such a high density that light itself cannot escape. But Woolsey proposes that some of the star resists getting sucked into the center of the black hole. As a result, a high-speed spinning disk of matter forms around it. Within seconds, jets of plasma shoot out from its rotational poles. These beams of energy unleash dangerous gamma rays into space.
If you can imagine just trying to squeeze a fruit or some kind of sphere of some object into a very small space, things are going to squirt out. And in this case, the squeezing is done very rapidly, and you're talking about a huge amount of mass.
At the same time the gamma ray bursts are ejected, the collapsing star explodes or goes supernova to the extreme.
One of the reasons gamma ray bursts are so incredibly bright is that they take an enormous amount of power and then they focus that power into a very small portion of the sky. For every 300 gamma ray bursts that go off, only one is pointed in our direction, and so we only see one of those 300.
Even if a gamma ray burst were to occur not 100 but 1,000 light years away, the Earth could still face apocalyptic destruction.
If a gamma ray burst happened within 1,000 light years of the Earth, then it would be approximately 500 times brighter than the Sun and emitting gamma rays. The energy delivered to the Earth's upper atmosphere would be like 100,000 megatons of nuclear explosions. The ozone would be depleted. We'd have acid rain, but we'd also have flash burns, incineration of vegetation, perhaps something resembling nuclear winter. So there could be a global extinction of many species. Now, the far side of the Earth would be a special place to be, because gamma rays don't go through the Earth, and if you were on the other side, you wouldn't get flash burn. But the effects of depleting the ozone and changing the composition of the atmosphere would eventually come to the other side, and there the effects are unknown.
Statistically, this ghastly scenario has a 1% chance of happening once in the Earth's entire lifetime. But even these odds aren't reassuring if you're living on the planet at that very moment.
If you're caught in the beam, that's a bad day for you. If one of these happens in your galaxy and that beam is coming your way, go hide in a cave, because this is very high energy radiation. It's the kind of energy that will decompose your molecules, and you just don't want to be around when that's happening.
There currently are no defense measures to shield us from gamma ray bursts if they happen close to Earth. They travel at the speed of light, 186,000 miles per second. By the time we detect